One of these is not like the other. Your learning targets for this skill are: I can use equivalent ratios to describe scaled copies of shapes, and I know that two recipes will taste the same if the ingredients are in equivalent ratios. This first example we're going to call mystery mixtures. Suppose you have 3 different mixtures of Kool-Aid. Here are the recipes: 1 cup of water with 1.5 teaspoons of powdered drink, 2 cups of water with 1/2 teaspoon of powdered drink, and 1 cup of water with 1/4 teaspoon of powdered drink. Which mixture would taste different? Explain how you know. Well, to do this problem, we would have to think about the ratios: 1 cup of water to 1.5 teaspoons of powdered drink, and 2 cups of water with 1/2 teaspoon of powdered drink. So that would be 2 cups to 1/2, 0.5, and 1 cup of water with 1/4 teaspoon of powdered drink. So 1 cup, 0.25. Okay, so which one seems different? Well, it seems like the most different is this first one. This first one only has 1 cup of water, but it has a lot of the powdered mix compared to the others. The others are smaller decimals, and this one is more than 1. So it would make sense that the first one, mix 1, or mix A, I guess, would taste different. It would likely be much stronger. Now, the reason this, maybe seems to make sense is because there is a lot more of the mix to less water. There is more mix to less water. So that could be your reasoning. Then we have this next one. Which of these recipes is for the stronger tasting mixture? Well, we kind of just answered that question. The solution would be mixture A would taste stronger because there is more mix to 1 cup of water. For this next example, we're looking at these different pictures of these moons. What do moons A, B, and C all have in common that moon D does not have? Well, there could be a lot of answers that you could answer on this one. One thing that seems kind of obvious is D looks like it's been smashed down. Another way to think about it is it also looks like A and B and C are all taller than they are wide, and D is wider than it is tall. So that would be another difference. The width is greater than the height. That would be another unique thing about moon D. Now, how can we use numbers to describe how A, B, and C are different from D? So now if we were to use numbers instead of just like looking at the picture, what could we say? Well, we could look at it right in the way that we were looking at the height and the width. if we looked at those heights and we kind of boxed them in like that, then we could just look at the height and the width of the boxes. So that could be one way to assess the pictures. Draw a box around the moons and find the height and width. All right, so if we draw our boxes and then we find all of our heights, then we would get 12 for the height of A. And then if we counted the width, we would get 8. And then we can go to the moon B, and then we would count 6 for the height and 4 for the width. And then we're on moon C, and that would be 3 for the height and 2 for the width. And finally, for moon D, we would have 4 for the height and 6 for the width. So now, when we're trying to compare them, we would just find the ratio between each of them. So, like it says height divided by width. So 12 over 8, we could simplify to 3 over 2. And for the next one, we have 6 over 4, which we could simplify to 3 over 2. And the next one, we have 3 over 2, which is already simplified. And then finally, the 4 over 6 would actually end up simplifying to 2 over 3. So this one is different. As a ratio of 2/3. And the others, A, B, and C, have a ratio of 3/2. So some things that we were trying to get out of this lesson were in what important ways were the drink mixtures the same and different. So thinking about how when we put more mix, we got a stronger flavor. More mix for the same water was a stronger flavor. Also, for another example, how could we use ratios to tell that things were the same or different? Well, if the ratio simplified to the same, then the mixture was the same or the ratio was the same. Then we looked at the important ways that the moons were the same and different. And in this case, I mean, they were all moons, so that was the same about them. They all we knew that they were moons. And you might have noticed that the ratios were reciprocals of each other. But really we noticed that 3 of them were like tall and skinny, and 1 of them was short and wide. So A, B, and C had a ratio of 3 over 2, and D had a ratio of 2 over 3. And the last part was, how could we tell using numbers that these were the same and different? Well, and that goes back to our simplified ratios. The simplified ratio of the first being 3 to 2, and the second one being 2 to 3. Since these are not equal, they were not all the same. They were not equivalent. And that's it for your notes on one of these is not like the others. Make sure you bring questions to class where we're going to do more practice and then do some check your understanding.